Hello, my name is Oliver Compton, and here's my senior project TED Talk. Yeah. Imagine a hiker goes hiking in the La Plata Mountains. They fall and they get injured. They don't know where they are, and they need medical help. They call for help, and a search and rescue team gets deployed. The search and rescue team needs a drone that can fly far, cover distance quickly, scan for the patient with a thermal camera, and drop vital medical supplies. Instead, the search and rescue team comes to the scene with two drones, with two different operators, two different batteries, and two different sets of problems. One drone is used to fly far and scan for the patient and find them, and then the other drone can drop medical supplies. The other option would be to call in a helicopter. That takes a lot of extra time, money, and it is risking more people since you have the flight crew of the helicopter also out there. It's just dangerous to fly. This thing is not. Oh, all right. My experience and passion. I started building remote control planes when I was very little, and I started tinkering with drones a little bit after, and doing this when I was at a very young age sparked my passion for aviation, and I have experience building and flying different drones, like here's me with a bunch of different drones, and then I brought in, this is one drone that I built right here, and you guys can pass that around, and then this is also another drone I built, but it's a little bit harder to pass around. And I also have my Part 107 drone license, which means I'm qualified to fly a drone for pay, or for like commercial purposes. And I also have my private pilot's license, which has helped me get a better understanding of it, like aviation and aerodynamics and everything that goes into building and designing aircraft, whether it be a drone or like a real airplane. All right. My senior thesis research question is, how can a drone be designed and built to serve multiple commercial purposes while also being engineered for optimal performance and efficiency? After doing all of my research in my essay and everything that's led up to this moment, I have tried to answer this question, and it's come down to four main barriers that are keeping us from having one drone that can complete all the different jobs of all the drones that are currently out there. Energy, structure, legality, and cost restraints. So all of these barriers are limiting our drones that are being developed to take over more jobs in society. Battery and energy constraints are one of the biggest limitations, because the current batteries that are out there for hobbyists and commercial operations and everything from like camera drones to drones used in war are they're all using pretty much the same batteries, either the lithium ion or lithium polymer batteries. And I also brought one battery in because this is a lithium ion battery, and if you feel it, it's pretty heavy, and that matters a lot. And so when that battery has a limited amount of storage, and if you, let's say, want to fly for a longer time, you might think, well, just add more batteries, but that also adds more weight, and that creates a cycle of, if you add more batteries, that adds more weight, and then that also decreases the performance of the drone, and then you can't just do that forever, So typical batteries like lithium ion and lithium polymer batteries range from around 180 to 250 watts per kilogram of like energy density. And then over here, this is called a solid state battery, and it has a much better energy density from around 300 to 400 watts per kilogram. And the big difference is it has a solid electrolyte instead of a liquid electrolyte. And so these batteries are around like 5 to 7 years out from mass production. And then the next barrier that we have is structural and material constraints. This is a really big constraint because the current materials that we're making drones out of are carbon fiber and titanium and aluminum, and these materials are very hard to manufacture, or they're expensive to manufacture, and in order for it to be widespread, you want something that's cheap. And so until these materials become cheaper, we will not see like wide-scale, like multi-purpose commercial drones. For example, like this drone, it's a DJI Maverick Air 2, is made out of plastic, and it's much cheaper, but it's also easier to make. And then cost, that brings us into cost. These drones, like this one right here, the smaller, like single-use drones, are much more cost-effective to buy and to operate. For example, if you were to have a multi-purpose drone that completes a lot of different missions, it would cost a lot more to maintain and a lot more to buy. Our next big constraint is legal and like basically the FAA. So the FAA has a lot of different restrictions of drones through the Part 107. Like the Part 107 is a set of rules and regulations that the FAA put out so that drones fly safely with other aircraft in the sky, but they're also very restrictive. For example, you can't operate a drone beyond line of sight of the operator, and you can't fly above 400 feet. And in order to do missions where you're going out and, like, let's say, searching for a person for like search and rescue, you would need to get a waiver ahead of time, which is not always doable for, like, let's say, search and rescue. But even if you wanted to do like a research project with a drone, the waivers are very difficult to get, and they take months up to even years to acquire. And so what does the ideal drone look like? The ideal drone looks like it would be able to carry a lot of different payloads, so different cameras, and then also different like droppable payloads, like let's say dropping medicine for someone, or dropping a package in like a remote location. So it would need to be modular in what types of things it can carry. It would need to have a long range, and that's either done by more advanced batteries, such as the solid-state batteries, or having like a hybrid electric drone with a gas motor. The drone would need to be able to take off and land vertically, and then also fly in flight more efficiently, like an airplane, just like cruising, flying on wings rather than like a traditional quadcopter. And then the drone would also have to be ready for any type of weather that might come, like wind, rain, dust. So it would have to have a high IP rating, which is like a sealant like rating, so it's sealed off from the elements. And so what I've learned is that right now we are not able to build a drone that can complete all the tasks of all the drones that are out there right now, but what companies can do is they can make more versatile drones for the kind of like genres of tasks that they'll be doing. So a camera drone could be equipped to change out from like a thermal camera to a LiDAR camera to normal like cinema camera, and this would make it so that drone operators have to only have one drone that they're worrying about in their fleet, so they don't have a bunch of different drones, and over time it would make it more cost effective.
Sorry.
I feel like this battery might be killing me.
Yeah, I'm gonna find a better one. Sorry about it.
And so, yeah, once these issues or these like regulation or restricting barriers are addressed, then we'll be able to create more versatile drones that will help take over all kinds of different jobs in society, from like agriculture to medicine or first aid to like everyday like Amazon packages coming to your door. And once the operators and companies realize that the importance of switching to versatile drones, then they will have a head start on everybody else and redefine the drone industry. So thank you for watching.
All right, we are gonna ask you some questions now. And you guys, this was always scheduled slightly into lunch, so thank you. If we go a little bit over, bless your hearts. Okay, what questions do we have?
I guess I'm not sold on why we don't just have different drones for different purposes.
Yeah, I had the same question.
What's wrong with having like, Amazon wants a drone that can deliver packages, Search and Rescue wants a drone that can find things. Like, why wouldn't we just design them with the tools we have to do the tasks that are
Yeah, so for many uses, drones can be designed for just like single use missions for like Amazon and Amazon like designs a drone for packages, and another company designs a drone for another thing. But this is targeted more at the like commercial operator of a drone that they have like, let's say, a business. For example, I did like a small internship a few years ago with a company called Lost Bird Productions, and they do filming, they do like agricultural like surveying and different like LiDAR scanning of like like rocks in the ground and stuff like that. And this would be targeted more at those operators where they have a bunch of different drones for a bunch of different uses, and it would be overall cheaper and more efficient just to have one drone that could do it all, and just swap out different payloads instead of buying different whole drones. Yeah.
You mentioned like the solid state batteries.
Yeah.
What's like a current like limiting factor that's like stopping them from being
I have in my essay a couple of resources or articles for that, but one that comes off the top of my head would be there's not enough companies that are like invested in solid state battery like development, and it's not really it hasn't really caught on yet. Yeah.
Are they using them for anything else? Solid state batteries? Like in electric cars or anything like that at this point?
I'm not sure, to be honest. I think they're being used in electric cars, actually. Yeah, there was one article that I read that was talking about solid state batteries being much more efficient for electric cars, yeah.
And what are they made out of?
Solid state batteries are made out of ceramic, here, if I go back. Oh. So basically, the big difference is the electrolyte is made out of like a ceramic polymer rather than a, like a liquid electrolyte. And I'm not completely sure what a liquid electrolyte is, but yeah. I don't. Yeah, I'm not sure how to best explain that.
Can you use an alternative fuel to propel the drones, like gasoline, or make it that type of thing?
Yeah.
Is that, well, I mean, I would imagine that would be lighter, it's a light, you know.
Yeah, there are drones out there that have like a hybrid system that they can take off and land vertically with electric power, and then they can run like in flight off of gas power, off of like a small internal combustion engine. And yeah, that's being done a lot, but they're also very expensive, and they don't. They're not very like user friendly either. Yeah.
What about solar panels on the drone to help keep the battery charged during flight?
Yeah, I saw there's one drone that is made by NASA, and it's basically a massive wing, and that thing does have solar panels on it, but it's not very plausible for like the everyday like user that like that drone is much larger than